Nothing. Can you tell me the name of this pin? Anybody?
Yes,
Yeah.
sir.
Name of the spin is what? Anyone?
Sir, Kundusi.
Yeah, Tamil we can say Gundusi. Telugu also Gundu pin. In English name we used to call it as one of your friend name, but spelling is changed. Alpin. We have Alpin. Here Alpin it is. Understand Alpin? So this Alpin, just if you notice a tip of a Alpin in a STEM technology, you remember billions of atoms will be present. It's just a tip of a Alpin. Imagine how small it is. So that much smaller the atoms, we cannot even see with the powerful microscopes also. So too much of extremely smaller. So now that's why we can say, if even our book you can notice it, silicon structure they have given. So that is the magnified structure with the STEM technology. This is the structure of an image of the surface of a silicon. You can see how the atoms are. It is actually take an enlarged view of a surface of silicon, which is taken by STEM technology. Which is taken by what technology? STEM technology. Do you understand it? So STEM technology will take the atoms of a given substance, and if you have taken and if you zoom it, then you will get it, the individual atoms you can notice. Even this picture is not clear. You can see in the Google, so you can work out many things you can notice. Yes.
In the book, they doesn't give the proper definition of atoms.
Yeah, they won't give, they will just say you, that's all. They are saying something story like your room, you can see the walls of a room and then a collection of rooms to form a building. What is the building blocks of the huge building? What is the building blocks of huge building? What is the bricks? Correct? Am I right or wrong? So bricks is considered as an atom. That's what their story there is. Purima?
Yes, sir.
Yes. Then if I consider as a brick is a big building, then brick inside sand, cement, other small stones, each one is an atom. That's all it is. Clear? Yes?
Yes.
Yes. So this is what you can see. You just imagine how small it is. One small alpine contains a tip of alpine contains a billions of atoms. So you can see that this size of an atom basically is extremely smaller. So that is what we used to represent. The radius of the atom is represented atomic radius, right? The size of an atom, the size of an atom is represented by its radius, which is known as atomic radius. What is that, everybody? Atomic radius. Okay. And remember, this atomic radius is measured in nanometer. So what is the unit of atomic radius, everybody?
Nanometer.
Nanometer. Okay. So nanometer is one of present trending technology is nanotechnology. But even our ancient time, even from the Chhatrapati Shivaji time, and even the 1,000 years pillar, there is a pillar, iron pillar in India, where it is located, Delhi. Almost 1,600 years before, they have been quoted the pillar, rust pillar. Till today, it is there without a rust. Understand? Without formation of a corrosion or rust. So that much it is actually. Okay. Even presently in a robotic technology, they are developing a nano robots where we can potentially deliver the drugs to the cancer cells, like particular targeted organs of our body. We are sending the nano robots are there, which is doing the operations, which is giving the perfect damaged cells. We are carrying the medicines. So the technology, smart material and the technology where will develop extremely smart, very smaller and finest one. The technology, we used to call it as a, what technology, everybody? Nanotechnology.
Nano.
Yeah. So technology, we used to say. So this is not, for world it is new, but in India, Indian history, it is very old topic. So nanometer is the one which will use to measure the atomic radius. That's what size of an atom. So nanometer is the smallest unit of measurement, as it is 1 billionth of a meter. 1 billionth of a meter. So remember, nanometer is
1 by 10 power 9
yes,
minus 9.
1 billionth of a meter means 1 meter is equals to 1 by 10 power
Power
9
9.
nanometers. Sorry, mistake. Sorry, 10 power 9 nanometers. Reverse. 1 meter is equals to 10 power 9 nanometers. Nanometer symbol is nm. Reverse relation. 1 nanometer is equals to 1 by 10 power 9. 1 by, that's what? Billionth. 1 billionth of a meter. 1 billionth of a meter. So 1 by 10 power 9, I can write as a what? Everybody. 10 power minus 9 meters. That is the answer. So 1 nanometer is equals to how many meters, everybody? 10 power minus 9 meters. Clear? Yes, Agalya, Prithvi. Any doubt, you can ask me. Sam? Okay, Tambi?
Yes, sir.
Do it, everybody. Hasini, Gokul. Okay. So now, if you have noticed it here, Lingesh is there. Gokul, Kishore is not there, I think. Kishore is also there. Okay. So now, then if you take your book also, they have given that. This also you can learn, because you cannot say they have not given. So they have given here, what is the relative sizes and example. If I take hydrogen, what is the atomic radius in meters? Check it. What is the one atom of hydrogen if I take? What is the size? Have you checked it? All of you? What is the size of hydrogen atom?
Power minus 10.
10 power minus 10.
10 power minus 10, what it is actually? Meters.
Meter.
Understand? Which is approximately, if you have taken in nanometers, don't believe, atom of an hydrogen is 0.037 nanometers. Like that, you can take anything, just convert it, that's all. Meters, you multiply with the 10 power minus 9. That's all, you will get it. Okay. So 10 power 1 by 10 power 9 meters equals to 1 nanometer. 1 meter is equals to 10 power 9 nanometers. This 1 by 10 power 9 only, I can write it as a what? Everybody. 10 power minus 9 meters.
Minus 9.
Understand? Ma, please understand, Amma. Clear, everybody?
Yeah.
Yes. So you can see the size of atoms are of the order of 10 power minus 10 meters. Order of atoms. If you have taken every atom, if you take, for example, if you take hydrogen, carbon, oxygen, phosphorus, sulfur, iron, copper, lead, whatever it is, it is found that calculations, the atom size are in the order of 10 power minus 10 meters. Please note it. This is the order of every element. Suppose hydrogen. What is hydrogen? 0.37 into 10 power minus 10, which is equals to 0.037 nanometers. You understand, Mari, what I'm saying? Clear, everybody? If I take hydrogen, for example, sulfur. If I take sulfur, all of you listen. Sulfur is 1.04 into 10 power minus 10 meters, which is equals to 0.104 into 10 power minus 9 nanometers. Sorry, 10 power minus 9 means what? Nanometers. So 0.104
Sir,
nanometers. Do you understand?
no one doubt, sir.
Yes.
Sir, for all the atoms of an element,
All the atoms of an element, they are in a power of 10 power minus 10 meters order. Clear?
yes, sir.
Size is somewhat different, but into 10 power 10 is 10 power 10 meters is common for every atom.
Yes, sir. So you're multiplying 10
Yeah.
power minus 10 with
10
0
power minus 10
0.37.
meters. 10 power
What
minus
is the 37, sir? 0.37.
0.
What is
Yeah, see 0.037. So basically 10 power minus 10, can I write as a 10 power minus 9 into 10 power minus 1?
yes, sir.
10 power minus 9 is a what? Nanometer. Do you understand?
So what is that value? So 0.37.
That is the size of a one hydrogen atom. Size of a one hydrogen atom is 0.037 nanometers.
Yes, sir.
Clear? All of you?
Yes, sir.
Understand, everybody? Yes, please. Suppose, for example, let me take gold. So it's a favorite for the girls. So gold basically 1.44 into 10 power minus 10 meters. This is the size of a one gold atom. Write in the nanometers, everybody. What is the right in nanometers? Gold. Yes, please. 0. Or else let me write like this only. 1.44 into, can I write Agalya this one? 10 power minus 9 into 10 power minus 1. Am I right or wrong? Meters.
Yes,
So
sir.
10 power 9 minus 9 is a what actually? 10 power minus 9 is a what? Nanometers. And 10 power minus 1 means decimal will go forward. So 0.144 nanometers. Any problem for anybody? I hope you all understand. Clear, everyone?
Yes.
Yes? Please respond.
Yes,
So,
sir.
how I am saying the size of an atoms are the order of 10 power minus 10 meters with the calculations. After calculating the size of most of the atoms are found to be that the size of the atoms are the order of 10 power minus 10. 10 power minus 10. Clear, everyone? And your book they have given here. Molecule of water, 10 power minus 9 meters. Means equals to how many nanometers? How many nanometers? 10 power minus 9 means? Nanometer. 10 power minus 8, 0.1 nanometer. 10 power minus 4, what is that? Everybody. 10 power minus 4. So 10 power minus 4 into meter means 10 power minus 9 nanometers. Am I right? Correct? Meters. So which is equals to 10 power minus 13 nanometers. Puremara, ellame, understand? Yes? Please respond. So
Yes, sir.
we have to be very precise calculations. After the calculating many values, many structure of atoms, we have been found that all the elements, this is not elements. These are giving grain of a sand, ant, apple. Apple size is 10 power minus 1 meters. 10 power minus 1
Sir,
meters.
one doubt, sir.
Yes.
Sir, in finding the value of hydrogen, you have written the unit as a nanometer, sir, but in the calculating time, you have used it as meters, sir.
That's what
How
I'm
did you?
saying, Mari. The size of the atom is, I'm saying hydrogen atom, 0.037 nanometers. 1 nanometer means, if you want to write it as a meters, 0.37 into 1 nanometer means 10 power minus 9 meters. Am I right?
Yes, sir.
Now this one, can I write it as a 0.37 into 10 power minus 10 meters? Right only, yeah? That's what I'm saying.
Yes.
10 power minus 10 is a factor of 0.37. Clear?
Yes, sir.
So every element is the size of atoms are the order of 10 power minus 10. So there will be some number in the front. That's all it is. No other difference. Clear?
Yes, sir.
Yeah. So this is what is about. So please learn 1 nanometer equals to how many meters? Everybody? That is only most
10
important.
power minus 9.
1 nanometer is equals to 10 power. Everybody?
Minus 9 meters.
Yes, 1 nanometer is equals to 10 power minus 9 meters. And 1 meter is equals to how many nanometers? 10 power
10 power
9
minus 9.
minus 9 illa, 9 nanometers. Puri mama, girls, Everybody?
Yes.
Yes. So please learn till here you finish it. I hope you all understand. Only two concepts only we studied today. What an atom is, second concept. How big are the atoms? Then next class, tomorrow we'll study what is the symbols of elements, Dalton symbols of the elements, and modern symbols of the elements. Firstly, we'll go to the rules for writing the symbols of an element, and then significance of symbols. Mostly up to till there we'll finish it tomorrow. Then 1/3 of the chapter will be over. Okay. So symbols and their significance. So up to that we'll study. Later we'll directly go to the a concept, call it as how do atoms existing and what is the way we will calculate the atomic mass, atomic number, that all things we'll discuss it. Okay. So this I'll stop and we'll meet in the next class. Thank you, everybody. We'll meet in tomorrow.
Thank you, sir.
Thank you.